Welcome you all to the video lecture on signals and system. Today we are going to solve the differential equation with the initial conditions. So the differential equation is d square y of t by dt square plus 4 dy of t by dt plus 5y of t equal to 5x of t, and y of 0, the initial condition, the y of 0 is equal to 1, and dy of t by dt at t equal to 0, which is nothing but y dash of 0, which is equal to 2, and input is given as x of t equal to u of t. So this is your differential equation in time domain. So we can apply the Laplace transformation in order to solve this problem. So generally the Laplace transformation of d square y of t by dt square is, since we have d square by dt square, first term is s square y of s minus, so reduce your power s, and first initial condition is y of 0 minus the next initial condition is y dash of 0. Okay, so like this you have to write your Laplace terms for the given differential term, and Laplace of d by dt y of t is, again for d by dt it is s and y of t it is y of s minus, so since s power 1, the next it will be of s power 0, so it is 1, so no need to write that, and first initial condition is y of 0. For example, if you have Laplace of d cube y of t by dt cube, then you have to write as, for d cube by dt cube it is s cube, and for y of t it is y of s minus, reduce your power s square, and first initial condition is y of 0, okay, and then minus, reduce your power, so s power 1, next initial condition is y dash of 0 minus, reduce your power, it is s power 0, so leave that, next initial condition is y double dash of 0, okay. So like this you have to first, for the given term you have to find out the Laplace equation, okay. So in the question they have given that this is the equation. So for d square y of t by dt square you can apply the formula. Similarly for dy of t by dt you can apply the formula as what I have given. So 5y of t means it is just 5y of s, for 5x of t it is just 5x of s, okay. So the given equation, d square y of t by dt square plus 4 dy of t by dt plus 5y of t, which is equal to 5x of t. So apply the Laplace transformation. So for this term, since they have given initial condition, we are considering the initial conditions, okay. If they did not give initial condition, no need to consider these terms, that is y of 0, y dash of 0 and all. So for initial conditions we have to consider the terms like this. So for first term we can write s square y of s minus s y of 0 minus y dash of 0 plus 4 is constant which we have to take outside commonly, okay. So d by dt y of t is s y of s minus y of 0. So you have to remember that 4 is common for both the terms, so write properly 5, and then for y of t it is just y of s, okay. So Laplace of y of t is just y of s, and the Laplace of x of t is just x of s equal to 5 into x of s. So once you have done that, then let us separate your y of s terms, okay. So what are all the y of s terms that we have to separate, and for that again what is y of 0, y dash of 0 value, those things you can substitute. So y of 0 is 1, y dash of 0 is 2. So this value it is 1, and this value it is 2. Similarly this value is 1. So you can use that and you can substitute your values. So now you have s square y of s minus s into 1 is s minus 2 plus, and simplify your term, 4s y of s minus 4 into 1 is 4 plus 5 y of s, which is equal to 5 x of s. So now take your y of s commonly outside. Here you have, so what are all the terms with y of s? This term and this term. So what are all the coefficients? Here it is s square, here it is 4s, here it is plus 5. Okay. So all other terms you can take to the right hand side. So here it is minus s, when it goes to right hand side it becomes plus s, and then here minus 2 minus 4, when it goes to right hand side minus 6 will become plus 6. Okay, so once you have done that, then you keep your left hand side term as it is. Why? Because you just substitute what is x of s here and simplify your right hand side properly, and then you can bring your left hand side term to the right hand side. So here in the problem they have given that x of t is u of t, that is your input. So Laplace of x of s, so I can write x of s is Laplace of u of t is what? 1 by s. Okay. So wherever I have x of s, in this problem they have given x of t u of t, so x of s is 1 by s. So substitute that. So keep your left hand side as it is. First simplify your right hand side, which is 5 by s plus 6. Okay. So now LCM of the right hand side term is s. Okay. So 5 you can keep as it is and multiply. S into s is s square, s into 6 is 6s. Okay. So once you have done this, take your left hand side term to the right hand side. So y of s I can write it as, so first I am writing s square term, then s term followed by constant. So 6s plus 5 divided by, here already one s is there, and then you are bringing this term to the denominator, s square plus 4s plus 5. Okay. So numerator is this, denominator is this. Okay. So once you have done that, now we need to factorize this term. Okay. So use your calculator and factorize this term. Okay. That is press mode. Okay. And then until you get equation, press your mode. Once you get equation, press right arrow, you will get a degree. In the degree, you give the value as 2. Okay. Why? Because it is s square term. Then give value of a. A is s square coefficient, that is 1. B is s terms coefficient, it is 4. C is constant term, that is 5. So give these values and press equal to. You will get some poles, right? So when you see in your calculator, it will be of real and imaginary. See your right corner in your display of the calculator, you will get R and I. R and I means that it is real and imaginary. The roots are complex roots. Okay. So you cannot write your second term as b by the term, c by the term. Okay. It is complex roots, so you have to write it as bs plus c. Okay. So since you are getting complex roots for the second term, okay, I can apply the partial fraction as a by s. Okay. Second term it is bs plus c divided by s square plus 4s plus 5. Okay. So once you have done this, then we can proceed with the partial fraction. So left hand side is s square plus 6s plus 5 divided by s into s square plus 4s plus 5, okay, which is equal to a by s plus bs plus c divided by s square plus 4s plus 5. Okay. So, you have written the equation as this. So, once you have done that, keep your numerator term in the left side as it is, s square plus 6s plus 5 as it is, which is equal to, then denominator, see the denominator and compare with the denominator here. A by the term is s, s is already there, which term is not there, that you have to multiply with a. So, a into s square plus 4s plus 5. Similarly, bs plus c, okay. So, here the denominator is s square plus 4s plus 5, compare that with this, already that term is there, so which is not there, that you have to multiply here. Okay. So once you have done that, okay, let you simplify the term. A square plus 6s plus 5, which is equal to a square plus 4as plus 5a plus multiply this term b square plus cs. Okay. So now we can go for the either substitution or comparison. Okay. So anyway, we know that one term, okay, I can substitute easily. That term is here, since you have s, right, since you have s here, you can substitute s equal to 0. Okay. So your first substitution is s equal to 0. Okay. So when you substitute s equal to 0, here it is 5, here s and all 0, so only 5a is available. Okay. Other terms become 0. So a equal to 5 by 5, which is nothing but 1. Okay. So then I cannot substitute any other value here. So only possibility is compare. Okay. So the compare coefficient of s square first. Okay. So when you compare that, here s square coefficient is 1. Okay. Right hand side s square coefficient is a plus b. Okay. Already you have determined a value. Okay. So b is 1 minus 1, which is nothing but 0. So b value is 0. Then compare coefficient of s. Okay. So what is the coefficient of s? It is 6. 6 equal to here 4a and then this term, right? So which is c. Okay. 6 equal to 4 into a. A value is 1 plus c. Okay. So c is equal to 6 minus 4, which is nothing but 2. So c value is 2. Okay. So once you have obtained that, you can substitute in this equation. Okay. Here the left hand side is nothing but y of s. Okay. Y of s equal to this term. Okay. So you can substitute all those values there and you can determine. Okay. So what happened? Your y of s is 1 by s. Anyway, b value is 0. So 0 into s becomes 0 plus 2 by s square plus 4s plus 5. Okay, this is your y of s. So y of s is equal to 1 by s plus 2 by s square plus 4s plus 5. And again, since the denominator is having the complex roots, right, I cannot directly use this term and I cannot take inverse Laplace transformation. Okay, so I need to simplify your denominator term. Okay, so for that again we can rewrite the term in the denominator as s square. Okay, whenever you have the term like this, okay, s square plus 2as, okay, plus c square, okay, or c, whatever it may be. Okay. So for example, if it is c, okay, you can write this term as, okay, so divide this term, that is s coefficient always by 2. Okay, divide s coefficient always by 2. So I can write it as s plus, okay, divide this term by 2, so it become a, s plus a the whole square, plus always you have to write this as c as it is, minus this term whole square, that is a term the whole square, which is nothing but a square. Okay, when you want to expand this, you will be getting this. For example, here it is a square plus 2ab, sorry, 2ab is 2as plus c minus a square. Okay, so this and this get cancelled, you are getting s square plus 2as plus c. So this I can write in this format. Okay, so whatever s coefficient you divide by 2, okay, so it is a here, so 2a by 2 is nothing but a, so you are writing it as s plus a the whole square, plus write this term as it is plus c. Okay, and whatever you have given within the braces, right, that constant you have to square and subtract with the c. Okay, so using that formula, okay, anyway for 1 by s I have inverse Laplace directly, no issues with that. For the denominator alone you are changing it. Okay, so here the 2a is nothing but 4, 4 by 2 is nothing but 2. Okay, so s plus 2 the whole square, C value is 5, write as it is, minus this term square, that is 2 square. Okay, so like this you have to rewrite the expression. So 1 by s plus 2 divided by s plus 2 the whole square plus 5 minus 4 is nothing but 1. So 1 I can write it as 1 square. Okay, why? Because I have formula L inverse of, okay, L inverse of a by s plus a the whole square, sorry, L inverse of omega by s plus a the whole square plus omega square, which I can write it as e power minus at. Okay, here and here you should have same term, sin omega t u of t. Okay, so you have Laplace inverse formula like this. Okay, so when you compare this and this, okay, here omega value is nothing but 1. Okay, so omega value is 1, a value is 2. Okay, so using this formula I can write properly, I can take inverse Laplace properly. Similarly, L inverse of 1 by s is u of t. Okay, so now we can apply inverse Laplace transformation. So y of s will become y of t, which is equal to, for 1 by s it is u of t plus 2 you can keep as it is, and for this term, okay, you can use this formula and you can rewrite as s plus 2 means e power minus 2t, and 1 by s square plus 1 square is sin omega t. Omega value here it is 1, so it is just sin t u of t. Okay, so this is your final output. Okay, thank you, thanks for watching.